And today we're gonna be working on this airplane, a DR400. It's 140 horsepower. This one, it's a French Pierre Robin, which I fly. I'm gonna fly with this, and so just a quick outside circle view. The simple 4-seer single piston engine. It's not a retractable gear. They don't have retractable gears. So today we're going to fly with this one. I'm going to start showing you the instrument panel and explain the very basics. I'm not high level pro etc. Just for beginners, the very basics of a simple airplane and its instrument panel. So here you have the airspeed indicator, your velocity of relative airspeed in kilometers per hour outside. It's in knots in the inner circle, 50 kilometers an hour, and this is the white bow, which the upper limit is the flap extended limit, and on the other hand you need to make sure you're within this white circle before you extend your flaps. The green is the normal operating velocity. The yellow should not exceed 250 kilometers an hour in turbulent air, and in any cases you shouldn't exceed the VNE, the never exceed velocity, which is the structural limit of your aircraft. Here you have the artificial horizon. You can set this little airplane icon more or less high according to your height, and the background of this instrument will move, incline left and right, up and down, to show you your attitude. It's the attitude indicator. This is not necessary in VFR day flight, but VFR night VFR, you'll need this to know what's the aircraft attitude. That is the altimeter. The altimeter indicates the altitude and uses the pressure to do so, because in the atmosphere you have the standard atmosphere, international standard atmosphere, which defines certain pressures and temperatures. Basically, the higher you go up in altitude, you lose pressure. You lose 1 hectopascals every 28 foot. Yeah, that's right. 1 hectopascals every 28 foot climbing altitude. So this is the small arrow, which gives the thousands, and this is the larger one, which gives the hundreds. We're just under 1,000. We're at 860 feet QNH, so above the sea level. You can change this. You can see if you set this, you're going to change the altitude. What you're actually doing is setting your QNH of the day, the current pressure, to have a more precise reading of the, not precise reading of altitude, but just to be, every aircraft will set the right QNH of the day and you'll have the same standard conditions. This I think is, sure it's not a VOR DME, it's just HSI maybe, or almost ILS. I don't know exactly which one, but it's a radio nav instrument which will give you the glide slope, direction you need to go and land, basically. Now this is the suction indicator, which indicates the suction produced by an air pump, pneumatic pump, which feeds some of your instruments. Yeah. And turns the gyro. For many instruments like this one, the directional, the attitude indicator, you need gyros that spin very fast. Some of the modern gyros spin thanks to an electric motor, but some still do spin because of air. So when you turn on the aircraft, you have an air pump, creates pressure, allows the gyros to turn fast, and feed some of the instruments. It's got to be in the green because it's got to be giving enough air for the gyros to turn fast enough. Okay, this is the turn and bank indicator. It indicates your turn, left and right, and this is the bank indicator. If you're turning left, and you're turning left with as much as rudder pedal, which you control with your feet, as you are with your stick, this should stay in the middle. It's a simple ball in a fluid, damped by fluid, and it turns left and right. If your turn isn't symmetrical, it should stay in the middle permanently. And ideally, look, if you take off, you turn left, you need to bank on the left using your stick and your rudder, and they should both be in the right quantity, applied in the right quantity, and in that proper right case, this will stay in the middle. Okay, this is your compass, directional compass. There is a real magnetic compass. This is a gyro rate compass, which isn't perturbed in the same way by this one. This one doesn't indicate the right thing when you're turning left and right, when you're going up and down. It has a tendency to move. To avoid these errors of the magnetic compass, we use the gyro compass. But this will change a bit during time if you fly for many hours. Because of, I think, precession, if I'm not mistaken, this will move a bit, although it's quite negligible on short flights. You can adjust this, actually you should adjust this before you go off and fly. You should adjust it to the right heading, notably your runway heading. If we go out, you will notice a number on the runway over there. What's the number? I think it's 8 here. Let's go and have a look. Yeah, it's 8. So this runway is heading 80. In front you have the heading 80. So your instruments show about 80, which is approximately, 6, 7, 8. So that's approximately right. This is your vertical speed indicator in feet per second. Vertical speed, feet per minute. So a vertical speed is how many feet you're climbing per minute. This is in hundreds, so 100 feet, 1,000 feet a minute. It's your rate of climb or rate of descent. It has a time lag. It is not instant. When you start and climb, this will come up half a second later. This is another radio nav instrument, the ADF, I believe. Then here you have your radio com and radio nav. Radio com is here. You set a frequency here, so if we would speak on the radio, we would be on 128.90, and we could prepare another frequency, 122.30, which is the standby frequency. You're not listening to it, you're not speaking on it, but if you click here, you just switch from one to the other easily. It's just to keep a radio frequency in memory. This is the same to radio nav frequencies, and they're connected to these two radio nav indicators. Now, if you want to use VOR DME, or radio, any radio nav station on ground, you connect to the right frequency and it'll come up on these instruments. This is your squawk or transponder. It's an off, you want it on standby, X, PDR, X transponder, or test. Normally, if you contact the control tower, they will give you a squawk number like 4503. If you're in VFR flight without any control, you're supposed to put 7000 by default. The default code, if you are not given a code by control, is 7000. And So yeah, here is your off, transport and standby, and alt. Alt is altitude mode. That means your transport squawk is sending your altitude reading to the tower so they know what altitude you are at. Actually, more precisely, what flight level, because this is on standard 1013.25 hectopascals. It will read out a flight level calibrated in 1013.25 hectopascals. This is GPS. There are all sorts of GPS, more coordinates type, and the ones with maps are a bit easier to read. Just a bit lower, have engine indications here. The oil pressure, oil temperature, or is it the inverse? I can't see the pressure temperature symbol. This is your oil pressure and temperature. This is your RPM, rotations per minute. It's rotating at just under 1000 rotations per minute. You shouldn't exceed this. Your engine is not meant to exceed 27,000 RPM. And your fuel pressure on this kind of airplane, there are two pumps. There is a mechanical pump that turns with the engine, and here look, electric pump on and off. You put it on takeoff, on approach and landing, because there are critical phases of flight. In normal operation, your mechanical pump will be driving the fuel, and that'll be enough. In case of a mechanical pump failure, you've still got an electric pump to replace it, but you should go and land quickly, because if this fails, I remind you, it's a low-wing aircraft. Low-wing aircraft, the tanks, the fuel tanks are in the wings or underneath, and they need a pump to get to the airplane. On a Cessna 152, for example, when the tanks are in the wings, we don't need a pump at all, because it falls into the engine by gravity. Here are fuel quantity, 2 indicators, must be 2 tanks. I don't know what that is, I must admit. Carb heat, carb temperature maybe. And the flaps, there's even a flap indicator. Up, half out, and full out. And this is the battery on and off. This is the alternator on and off to charge the battery. This is your engine magnetos off, the right magneto, left magneto, and both. That feeds the spark plugs with electricity from the alternators to allow the combustion in your engine. Here you have the trim tab indicator, your brakes, okay, and your mixture, the richness of your mixture. Lean is there, rich is there. That's about it. That's about the basics. There's the alarm tab here. You have indications. You can test them to check if all the bulbs are working, oil pressure, temperature, fuel pressure, fuel quantity, engine, battery, flaps down, brakes. Basic airplane, basic functionalities, but here I really like basics, basic instrument. You have basic indications on how the airplane works. Let's just go for a short flight. View in circle. There are two notches of flaps. There we are, 1 and 2 down. Take off with 1. Take off with 1 down. I would just like to shut this before we take off. Shut the cockpit. Yep, I think that's about right. Yeah. Well, we're ready to go. Full throttle, brakes off. Now the engine is pulling me on the left. I'm needing to push the feet down, feet on the rudder right. There we are, takeoff. Flaps up. So, let's go back inside. Actually, I just wanted to show you a little landing, so I'll take the airplane, move it there, change the heading. On final approach, what's the altitude? 700, that's, yeah, okay, speed's fine. Anyway, there we are, it's just gonna load. And we don't need to make sure gears extended, they're on the gears. I'm reducing the throttle. Look at the speed. I'm just above the white circle, so I can't yet extend the flaps. I'm reducing speed. There we are, speed is falling. Carb heat is expected, so I'm gonna pause. And where's the carb heat? There's there. I'm gonna pull the carb heat. I'm now in the white circle, so I can extend the flaps. You can see the green alarm flaps down coming up. I need to accelerate. The fact is, on approach, you should be at 130 kilometers an hour. I'm at 140, a bit fast. Oh, 130, that's fine. Flaps down, just one extended. I need to extend both. I'll extend the second a bit later. Just get a bit closer to the runway and finals. I'm at 140 kilometers an hour, just lower down the engine a bit. Probably a bit high on the glide slope too. Don't have any PAPI indicator for this on this airfield. That's not too bad. A little bit fast. I'm gonna get out the second set of flaps. Wow, speed is dropping 120. I need to be accelerating a bit. 130, that is correct. 130 kilometers an hour, 120 no less. Just like in real. It's slow, yeah, but probably it's easier to learn on that sort of thing than on fast airplane, although probably less fun. Just a bit more engine, a bit more power. There we are. I'm going to show you outside for the landing. A bit brutal. Not as good as in real. Shall we taxi back to the hangar just for fun? Flaps up. What I should do, like in reality, is Now I'm landed, carb heat off, electric pump off, it's already off, it should have been on. Score it to standby rather than altitude. Just taxi back to the hangar. I should be calling control before penetrating on this runway. I'm just in a simulator, so I don't really mind, but in real life, yeah, you need clearance. Oops. There we are. And you shouldn't really get into anger with the engine on, but yeah, it's just a simulator, so enjoy it. There we are. Brakes on. Shut down the engine. And fill up all your papers and you're done. Hope you've enjoyed it. Do ask any questions you like on really simple technical things about instruments, etc. Or anything. If I got an answer, well, I'll just try and find the answer. So, like and subscribe if you're interested, and thanks for watching.